Now what I'm going to do is we're going to go into the product design construct. Um, and I'm just going to give you a crash course about product design. There's a lot of history that I could tell you about myself. There's a lot of stuff like that. But in this talk, I just really wanted to like impart my career really quick because my hypothesis is that the people watching this are visionaries, innovators, borderline crazy, and I mean that in the best way possible. And my goal would be if I can teach you all how to be product designers, then you can make all your crazy ideas real and we can all benefit. So that's my hope is like if I give this bit of a crash course and inspo. Some of you may already know this stuff, and I hope you would take it as just a reiteration of how important I found it over my career. But I know there's going to be a hackathon as well, so I was trying to also make it a little bit helpful for that context. But yeah, let's uh let's get into it. Okay. So there's something you got to know when you're building a technology is that technology is harnessed phenomena. So this is from a book called The Nature of Technology by Brian Arthur. Great book, but you can get kind of the whole one of the whole points with his one quote. When you're inventing stuff, you're creating with constraints. Technology is harnessed phenomena. I'm going to say it again because it's so important. Like an airplane flying, that's fire. It's exploding. We didn't invent fire. We didn't invent electricity. We didn't invent quarks and gluons. We electrons. We don't invent that stuff. We harness phenomena. So when you're thinking about inventing things, you can come at it from kind of two sides. You can look at what phenomena could I harness and do something with that, like a ground up approach. Or you could look, I have this imagination and I want to make it real. What phenomena and things can I do to work with that? So our imagination is within reality. So here's our good friend Leonardo da Vinci's imagination. And this imagination is within reality, right? His mind, all of our minds are inside of the universe. Okay. Maybe we are the universe as well, but we'll deal with that as we build products. But here's the thing. Reality has extra details. And Mr. Da Vinci didn't know those details. Okay. The reality of making a helicopter, this doesn't work. But it's a really cool imagination that leads us to, oh, here we go. I need to know more about the physics of how air is moving if I want to make something spin. So I'm showing this as an archetypal example of we might have an imagination or an idea, but you need to do the work of figuring out how the universe is going to actually support your idea because otherwise it'll just always be a sketch in the book, right? You'll be remembered in history as, oh, they were early and didn't know how it worked, versus what I would like is for in this century we don't just imagine things, we design a better world. And that's what I'm hoping, that's what I've been doing with my career. And that's what I want everyone to do, really. My goal would be I don't need a career. Everyone just knows how to design. Um, because I think of design as kind of like where you're bridging the gap between your imagination. You're going, because basically when you're trying to go from imagination to reality, it's going to put your personal imagination in touch with the shared reality. And the shared reality is not as kind and cozy as your imagination. It has other aspects. So design is going to navigate the translation of an idea to reality by accepting reality. You need to know the truth. So we work with things like user feedback and we have material constraints, we have physical, there's even economic constraints. I think of design as like a combination of science and art because you're not just making an art, you need to make something that works. And you're not just doing science because you're trying to change the world. Science often is about observing. Design observes, but it's like art, it acts and it makes. So you see what I'm getting at. It's this like unique place where you're saying, how might we build a helicopter? Is HMW, is a designer's favorite phrase. I'll go into that a little more later, but How might we, instead of saying, I'm going to build it as a propeller, hold on. How might we have a flying vehicle? Let's zoom out. Okay, let's have some ideas. Make some of those ideas, test them, reflect, iterate. This is kind of it. This is basically what design is. If you're willing and able to take the data you learn from and incorporate it into something new, um, you can make like anything. What's interesting is it might not be exactly what you imagined. And this is the part of being a bit cheeky and saying your imagination can actually be a liability sometimes, where you have to take it easy and take a step back and use things like how might we to say, instead of, I want to build a helicopter, how might you build a flying vehicle? You might end up with a drone. You could have done that 100 years earlier. Who knows? I know there were limitations. Um, Before I move off this, designkit.org is like from IDEO. If you want to go into this a lot more deeply, you can go to there. They have a ton of resources. IDEO is obviously the huge design thing. I did a mentor lecture for a XR design challenge that was hosted by IDEO. And so some of these things are, you can look at the talk more in the other resource that I'll share with you. So when we're building something, this is kind of a cute way of thinking about it. A lot of people do the top one. Like, I want a car. And then I'm gonna make a wheel, and then I'm gonna show it to somebody. I'm gonna do the bottom wheels, and everyone will hate this. You will get bad feedback as well. You're not providing value at step one, two, three, and four. You're waiting until the end. So this is by Henrik Knieberg. I hope I'm saying his name right. He drew this, but I've encountered this like personally firsthand. Don't show them, don't try to create stuff that doesn't work at all. This is particularly relevant for a hackathon, by the way. Do you see what I'm doing? Don't try to make things, if you have a vision, don't only ever work on it in pieces or whatever. You got to be able to also chunk it down into usable sections that will give you better understanding because they're actually doing something in the world. So, like, this is a bit of a misleading picture, I'm going to say, because it's not like the skateboard leads to the car. I don't think that's what this person's trying to say. It's not what I'm trying to say. It's more like if you can only afford or know how to build a skateboard, you're at least trying to get wheels moving forward. And that will let somebody else use your invention of wheels going forward and give you some feedback. So you can learn, oh, maybe you want to add more of a control system, and then you end up with a scooter. And then, oh, you know what? Actually, the wheels are too small. It's da da da. I'm going to change it into this. And then onward and onward. And so in this case, again, it's showing it like linear, but you might end up in your design process the first time you show them something, um, going somewhere else with it. So if you can combine having a vision of I want to get to something with I'm willing to hear what's happening and accept reality, you're going to be able to build more interesting things. So I am going to specifically go into as you begin building things and become a designer, there's a whole reality that I wish kind of I encountered earlier of just like straight up dealing with what people tell you about your idea. Like, so here's this meme. I don't know if any of you else are designers or work in the creative arts, but when a bunch of people give you feedback about stuff or you learn things by doing experiments, it can get a little crazy because you're going to have they don't understand what you're trying to do necessarily when you show it to people. When you have a vision or an imagination or whatever, uh, you can end up just kind of sitting in nonsense. Like, and if you were to do everything that people told you to do, you would end up like this gentleman looking at his terrible design. So I'm taking a detour of a specific method, which is coding your data. So you might not need to use this for the hackathon necessarily because you're not going to really have that many iterations. But I still would just urge you to think about this is this is propaganda for why you should do qualitative coding. Too long, didn't read. if you actually take a look at when you get your data and you try and figure out what each section of it is telling you, then you're going to have a lot better time trying to actually integrate and do product development. So instead of just like going from just the first demo is one thing, but to actually develop a product and start building a cycle of improvement, you'll need to have a way to actually like understand what people are telling you, and you're going to need to have a way to balance what you're hearing with what you're trying to achieve. So these are just a couple methods for doing it. You can do it from the ground up. Inductive is what it's called. You take your data and you say, oh, look, there's these themes in it. So data could be anything. It could be literally a comment that your mom gave you. Could be data, it's fine. Or it could be a straight up user survey or whatever. But the point is you're trying to get it to be in pieces so that you can like say, oh, this is a statement about a bug. This is a statement about they want it to work like this. This is something they're requesting. Like, how might we do this? This is something they hate. This is something they love. Stuff like that. And then once you can do that, then you can also go back down and say, all right, I have these things I'm looking for, these codes, and I can go deductive and look for them in my data. So if you're looking for like sentiment, or if you're looking for um, bugs or whatever, you can make all your different data sources can become one perspective that you get with your codes. So in reality, you're going to be basically doing a combination of these things. You're going to be um, having a hypothesis, testing, trying to figure out what happens, and then you're also going to be having your understanding of what's been going on and combine it together. So here's the little guy. He's not worried anymore. He's only imagining the dystopia of being disorganized because he lives in the utopia of being organized. And I've got to say, being part of multiple startups and starting up a startup in the form of Avatar Medic, um, if you can comprehend your data earlier, you'll be in a better place than not. So this is like I'm sharing this with you. It might be a little too far down the road, but I hope that you'll absorb the idea of like don't just listen to people, analyze what's being said about your stuff. So this is how I did it in a really simple way. This could work for a hackathon. Let's say you do it, let's say you make your thing, you do a test, and then there's a transcript of somebody using it. Like you're showing it to them and you're talking to them. And what we would do is go through and as we would take notes, if they said something like, "Oh, I really want to be able to like mash two proteins together and then see if they'll superimpose or whatever." Okay, we're not going to we'll note that as a how might we? How might we let them compare proteins? This interface, it's really like I'm having a hard time logging in. I can't find the thing. Okay, that's a UX and maybe a UI. Those get tagged. It's not working. Oh, I'm clicking the button, nothing's happening. And that's a bug. I really love this system. It's so great and it saves me a lot of time. Or I really don't like this. Those are like quotes. Those are potential quotes. So you can add multiple codes tags to your data. But the point is that instead of just having a giant transcript and trying to figure it out in your brain, the minimum viable way to actually like learn something from experiments is to break it apart into these pieces that you can use for other things. So just a little tips. Each data point is probably going to fit into more than one category. That's good. You don't want too many tags. So if you end up with like 400 different tags, you're not going to be able to learn anything. You're trying to aggregate, be able to say, here's all the things related to customer service. Here's all the things related to experience instead of like just having more text. Yeah. So starting small, like don't get over ambitious, and you can use scales and stuff like that. So I'm taking this. This is the full product. If you knew how to do this, you would be a product designer because that's what we end up doing a lot. Is like, yes, you build systems, you build interfaces, you build prototypes, but if you can't learn anything from your prototypes, then they're pointless. I'm going to go ahead and just say that. If you can't actually understand what's happening, then you're not going to like improve it into a product. You're just going to make a lot of demos, and you might even accidentally make something no one wants. So from doing experiments, you're going to organize your stuff and synthesize it all into a PRD. I'm going to go into that in a second. I think here's one more like example of how simple this could be. So, in the right category in particular, you can see it's got these tags. So you can do this in a table, you can do this in a doc, it doesn't matter. But I'm making the effort to tell you this because try instead of just hearing feedback from people or doing experiments, like give it a shot, do qualitative coding. But then, because what you're going to be able to do is create something that we call a product requirements document. So this is going to be you if you do this. You're going to be Neo seeing the code, which is why is this important? Because a product requirements document is like how you scope the effort you're going to try and put in. It the word requirements is very clear here. We want to say what are the constraints and requirements that must be taken into account in the design and development. Do you see why design, it's not just art? I don't get to just show up and make anything I want. Although you can as part of ideation and discovery. No problems. Like there's definitely room for pure art in design. But as an actual product, when you're trying to achieve something, you're going to have some requirements. You're going to have limitations. There may need to be specific things that it does for the user or what have you. And if you can articulate that early, and like you have to articulate it because the old jokes of designers is people saying things like make it pop. Okay, so how do I tell a developer how to make it pop? No, you need to be more specific, right? There should be a contrast between this element and that element. Oh, so in a lot of ways, product requirements documents, I'm going to go back to our friend Neo, because when you actually start doing this and you take your imagination, you start weaving it together with like, what are the requirements of each thing that we got to make? What are the limits? This is prompting in the new era. If you can, my colleagues and I would joke sometimes, eventually there might not even be programming. It'll just only be design. And you have to be very specific about what you're asking to be built. And so I, as a designer, work with developers right now, but this actually translates into uh, working with any construct who will construct things is can you be precise about what you're attempting to create um, and know what you're not attempting to create as well. So just like a basic um, perspective of this is when I've done the PRDs, you can make PRDs into like, it doesn't have to be like the document that explains everything about what you're building. You can have like different pieces. You can have like one per each experiment. You could have one per feature. But the point is, you're going to be able to track like what are your requirements? How have other people done this? What's the vision? How might we statements, if you have those from other things, you might be addressing. Somebody said, "Oh man, wouldn't it be great if you could do this?" And then somebody else said, "Wouldn't it be great if you can do that?" So now you have these two statements that say this and that. Can we work on them together? I don't know. So that's related feedback or prior versions. And then you have like your exact scope. So particularly for a hackathon, this is going to be a really big deal, but it's a big deal in industry too. What exactly can we achieve in the time that we have and the limits that we have? Like, what exactly are you going to do? So with the demos I showed you earlier, like robot arm control, it was a very limited scope. I'm going to get the digital twin to overlay on the thing, on the robot, and we can move it. It's a small scope, but it is situated in this larger requirement of we're trying to get the robot to be able to be taught by people. So it's a piece of a whole. And that's up to you. I'm not going to tell you how to do that because, to be honest, there's like 60 billion blogs about how to do that. You can pick your favorite one. But I just wanted to emphasize that, like, you have to eat your peas. You have to eat your vegetables um, of, organizing stuff. Yeah. Maybe we just have to be careful with the term open source, since that also means a specific software license. So I want to understand the question. I think what I hear in the question is inductive is like open ended, like you don't know what you're going to get, whereas deductive, you already know what you're looking for. Is that what was said or asked? Because that is how it works. Okay. Yeah, it's simple. It's just like, yeah, and you combine them together. So, okay. Any other? I will get to the XR stuff in a moment. We're actually right about to head into that. This is the end of the more boring section. I saved the I saved the interesting section for the end. I think they're just ready to make stuff. They're just like they're chomping. They're trying to go down this pipeline right now. I'm just gonna finish the pipeline of and if you've seen this before, I guess all why I have gone through all this is because this is my career as a product designer. So if you are a product designer already, you might be like, okay, whatever, dude, get to the cool stuff. If you're not a product designer, I'm just trying to tell you, like, this is kind of how we do it. We have a method, we have a way of approaching designing things. So it's why it's not quite art and we use science, but we are trying to change reality. So here's this really simple. This is basically like boils down my whole career to one diagram. You take your requirements of what you're trying to achieve, you design it, you develop it. There is a loop between design and development. There should be, because otherwise, you're not going to achieve success. Then you take what you've got and you test it with different folks, not just three people, but I always use threes because it's statistically significant. So if you're doing a hackathon and you can talk to and you can show your solution to three people to make sure it works, that would be like enough to say you can look at your what they tell you, because I guarantee you all three of them are going to tell you conflicting things, and that's why you have to code and collate and look at what's happening. Then you're going to distill and reflect that, and we would just talk with each other and just look at what's going on and do the basic product management thing of, all right, have we achieved what we set out to do and we could consider the feature or thing implemented, or are we going to need to take another crack at this? Did we learn new requirements? Did we find a new limitation? Are we going to have to try again? And that's basically it. If you can run something like this over and over again, you can take something that's completely impossible and just like chip away at it until it becomes real. And that's what the goal would be for all of everyone watching this is every idea you have, I want to enforce it can be achieved if you try and learn from each attempt. So now, if there are no other questions about this, oh yeah, well, let's pause for questions here, and then I'm going into the more like conceptual stuff. Yeah, yeah, exactly. Rapid prototyping is like sometimes this gets called agile, but um, like rapid prototyping means basically, yeah, you're going to do this quickly and try to learn and do it again. So instead of making just one, like remember the little car tutorial thing of like, instead of waiting for 6 months to show your users what you built, show them stuff every week, show them stuff every month. You know what I mean? Have something that exists each time that you can learn something from, even while it's still in the context of your vision. And that, if you connect those dots, then you'll make sure. Like, let's think about recently that humane AI pin that kind of spectacularly failed in the market because they waited forever to show us this thing. Like, could you imagine if they had engaged testers throughout their process instead of saying, ta-da, we have this thing and it's inaccurate? They could have learned that a long time ago. So I'm not trying to dunk on them, maybe a little, just maybe a little bit. Because in high technology, I have noticed a problem where people think they know. They think that their vision and their imagination is inherently valid and inherently real. And I wish they wouldn't. Because if Leonardo da Vinci had tried to learn about lift, I'm not saying he didn't, I know he was doing other things, but And the point I'm getting at is like, if you step out of only imagining it and try to make it in some form, even if it's just a prototype of like the idea to see how people will react or to see what's going on, everything you make to try to make something real is gonna get it closer to